In this video, I am going to solve the second problem from chapter 19. The speeds of 22 particles are as follows. Ni represents the number of particles that have the speed Vi. So here you have to see the chart. So in this chart, they give the number of particles here and they represent the number of particles here as Ni and its respective speed, which is Vi, and the speed here is in terms of centimeter per second. So two particles have 1 centimeter per second speed. Likewise, here 4 have 2 centimeter per second, and here 6 particles have 3 centimeter per second, and 8 particles have 5, and 2 particles have 6 centimeter per second. And for this, we are going to find what is its average speed and what is its RMS speed. Clear? And then finally, we are going to find the probable speed. So you have 3 questions in this second part. Clear? In this second problem, we have 3 subdivisions. So let's we start with one by one. So first of all, I'm going to find the average speed. And generally, we know how to find the average. So in the similar way, we are going to find the average for these particles. Clear? So we know the rule. The average speed is given by the term summation of Ni Vi over summation of Ni. So here Ni I have to mention as caps N here, clear, and Vi its respective speed. Understand? Okay. Now I am going to apply the rule for this case. Let's we start one by one. Understand? Okay. So the total number of particles is here. What is the total number of particles they mentioned in the question? 22 particles. So I can just write directly 22 here. Now, 2 particles has 1 centimeter per second speed. So 2 multiplied with 1 plus 4 particles have 2 centimeter per second. Likewise, we have to add 1 by 1. So 6 multiplied by 3 plus 8 multiplied by 5 plus 2 multiplied by 6. So now once you calculated, you will get the average speed. So let's see what should be the average speed for this condition. 2 multiplied by 1 plus 8 plus 6 multiplied by 3 is 18 plus 8 multiplied by 5 is 40 plus 2 multiplied by 6 is 12 over 22. So I got the answer here as 3.636. 3.636. And what's the unit? The unit here they mention as centimeter per second. So we have to write centimeter per second. So this is the answer for the first part. Clear? So now we have to jump to the second part. We are going to find the root mean square speed. Vrms stands for root, R stands for root, M stands for mean, and S stands for square. And for this, we are going to find what should be the speed. B part. Vrms is given by the rule square root of summation of the number of particles multiplied by its speed square over the number of particles. Clear? Clear? The total number of particles. Now I am going to apply the rule here. So let's start. Here n, better I can take the data from here because otherwise I have to move up and down. So 2 has 1, 4 has 2, and 6 has 3. So better I can use this for our second part. Clear? So 2 multiply with 1 square plus 4 multiply with 2 square plus 6 multiply with 3 square plus 8 multiply with 5 square plus 2 multiply with 6 square over the total number of particles they mention in the question here as 22. Now I have to solve this for getting the root mean square speed. Clear? Okay, let's we just calculate the top and the bottom in this equation. So square root of, so 2 multiplied by 1 is 2 plus 4 multiplied by 2 square. 2 square is 4. So 4 multiplied by 4 is 16 plus 3 square is 9. So 9 multiplied by 6, right? So 9 multiplied by 6 is 54 plus 5 square is 25. 25 multiplied by 8 here is 200 plus 6 square is 36. 36 multiplied by 2, we got 72 over 22. So now I have to add in the top. So 2 plus 16 plus 54 plus 200 plus 72. I got 344. 344 over 22. So let's calculate the final answer. So square root of 344 over 22. I got the answer as 3.954. So I no need to put the square root. I already calculate. So the final answer here is 3.954 centimeter per second. So this is the answer for the second part. Clear? Okay. Now we have to find what should be the probable speed. So for that, better I can give the answer here itself, because there is no respective formula for this type of questions. So we have to see the condition here. So what should be the probable speed? So for finding the probable speed, we have to identify the number of particles. So having the maximum, which speed should be maximum for the particle. So here, if you see here, we have 1 centimeter per second for 2 particles, 2 centimeter per second for 4 particles, and 3 centimeter per second for 6, and 5 centimeter per second for 8 particles, and 6 centimeter per second for 2 particles. So here, this 5 centimeter per second will be taken by 8 particles. So what should be the probable speed here? Because here this 8 is the maximum number of the particle which has the 5 centimeter per second, but in the other cases you have to see the number of particles are less than this. So here, if you want to give the answer for the third part, the probable speed, which is our third part of the question, the probable speed here is 5 centimeter per second. Why? Because there are 8 particles at the speed v, which is equal to 5 centimeter per second. So 5 centimeter per second is the most probable speed for this case. So the answer for the third part is 5 centimeter per second. Clear? That's it. Thank you.